of the 7-3 packet?
Number 3.
Number 3. I highly suggest that you're writing these down. This is X, this is Y, that's a right angle, that's 12, this is 45. What kind of triangle is this triangle then?
45, 45, 90.
45, 45, 90. First thing I want you to do with any of these triangles, regardless whether you're using sine, cosine, tangent, 45, 45, 90, 30, 60, 90, go through and label it. Sides across from the 45-degree angle, so he's got nothing saying, should be labeled what?
L.
Good. Side across from the right angle.
L right.
Now this is what you got to do. When you're using 45, 45, 90 or 30, 60, 90 and the rules about those, that's the one that we actually know a number for, so that's the equation we're going to set up. And the equation, you wrote this down for it, they told you this about it, you're just going to set those two equal to each other. L radical 2 equals 12. Don't forget to have a calculator next class. I will be checking. I already started checking with my other classes that didn't have the map test. So I've already started passing out detentions for not bringing a calculator to class. When we have this, I don't want you to do this all the time because on the test I know that there's some multiple choice questions, and on those multiple choice questions you got to know the answer in either form. But to get L by itself, all you really have to do here is divide by radical 2. Well, if you have your calculator like you're supposed to have, can you just take 12 and divide it by the square root of 2 and come up with a decimal answer? Yeah. So somebody tell me what that decimal answer would be, and we'll write it down over here. 12 divided by the square root of 2.
48.
So we'll say about 8.5. Now is that an exact answer? No, we rounded it off. To get an exact answer, I'll show you how to deal with the radical again. To get an exact answer, we take that form, multiply the top by the square root of 2, multiply the bottom by the square root of 2. On top, you can't really multiply those together because a regular number and a radical aren't the same kind of numbers. So you just write down 12 radical 2. On bottom, the whole purpose of doing this, square root of 2 times the square root of 2 gives you the square root of what? 4. Well, what is the square root of 4?
Yeah.
So now you're left with just 2 on the bottom. Once you get it to that, or get it that far, you can reduce that. 12 divided by 2 leaves you with what?
6 over 1.
So 6 over 1. Do we really need the 1 on the bottom? So 6 radical 2. If you take your calculator and figure out what 6 times the square root of 2 is, I'll guarantee it comes up to be that 8 point whatever that Alexis told us a few minutes ago. Again, this is an exact answer. Sometimes they're going to want the exact answer. This is your rounded off answer. They ask us to find x and y. Well, what is x then? 6 radical 2. What's y? 6 radical 2. That's both answers for number 3. Sometimes they'll ask you to solve a triangle, which we already did. When they ask you to solve a triangle, because I think there's some problems on the worksheets I'm going to give you today that say that, that means you want to find all 3 sides and all 3 angles. Well, they told us this angle, they told us this angle. We found that angle because we knew if this angle was 45, that one was 90, that one had to be 45. They told us this side, and we found the other 2 sides, so we solved the triangle. When you find all 6 parts, when you know all 6 parts of the triangle, all 3 angles, all 3 sides, that's solving the triangle. So problem 12 on the second page, right? Sine of b equals 0.2985. And we're looking for the measure of angle B. All you're going to do is take your calculator. You're looking for an angle. Remember, anytime you're looking for an angle, what's the first button you're going to hit on your calculator? You've got to remember that. That's the only time you're going to do that is when you're looking for the angle. You got to hit that second button first. So on our calculator, we're going to hit second. Which trig ratio do we hit?
10.
What's that tell us? Or what's it show us on our calculator? Your screen pops up as what? How's yours different?
Because with mine, I was.
Yeah, it should still show up the same, doesn't it? It doesn't.
I have to choose it.
It shows up, it should look sine -1. And what that's telling the calculator is to use that chart that I passed out to you, but use it backwards. And then you just punch in this number. Mine didn't work. Somebody did this on my calculator. What did anybody get since my calculator is not working right?
I have
17? Does anybody else agree with that?
I did that a long time ago. Before spring break.
So what's the measure of angle B? Does it make sense for angle B to be 17 degrees? Yeah. What numbers would make sense for angle B? Just a wide, broad range. Could be from what to what? Remember, you're always dealing with what kind of triangle? A right triangle. So if this is angle B right here, what could it be? Between what and what? 90 and 0. So 17 seems reasonable. Now, what I'm trying to get at is if your calculator's set up wrong, or if you make a mistake and hit the wrong button, like let's say I forget to hit the second button, and I just hit sine of 0.2985 and hit enter, it gives me 0.0052, and I set down to 0, but does that really make sense to be an angle, 0.0052, any kind of angle that we've ever dealt with in here? Probably not. Number 2, you have your triangle, it's a right triangle. This is R, T, S. And I know on number 2, again, it says to give the fraction form and the decimal form. Once you have the fraction form, how do you change it to a decimal form? Just divide. So I'm not going to do that. I'll put the fraction form up here for the first angle, and then you can do the second angle yourself, and you can find the decimal forms yourself. All right. They tell us little r is 10. Where does little r go in this triangle? All right. So it goes across from big R, right? So that's 10. What else do they tell us? So I don't have to keep looking back at my paper. Little s is how much?
24.
Do they tell us little t?
Yeah, it's 26.
Now, they didn't have to tell you little t. Does this fit one of the families? Families, remember, one of them was 5, 12, 13. What did they do to each of those numbers to get these two? Multiplied it by 2. So what do you got to do to the hypotenuse to get it? So what is it? All right, if you remember those families, remember, because on the test and stuff when we take it, I'm going to give you a problem. It might say 6, 8, and want you to find that. Well, you could use Pythagorean's theorem to find that, or you could realize it fits into the 3, 4, 5 family, and how long would that side be? 10. If you have to use Pythagorean's theorem anytime you know two sides of a triangle and you're looking for the third, then that's what you use is Pythagorean's theorem. Here, they gave us that. I'm going to get rid of this. It's not part of your answer. Which angle did they say? Angle R first. So we wanted to do the sine of angle R, cosine of angle R, and the tangent of angle R. They also want us to do sine of angle S, cosine of angle S, and tangent of angle S. And again, I'm not going to do it all for you. I'm just writing it up here to make sure you understand that you have to have all 6 of those answers. Remember your SOHCAHTOA for sine, cosine, and tangent. Sine deals with which two parts? Opposite and hypotenuse. So we need to label the triangle, which I forgot to do, sorry. What's that side going to be labeled? The opposite leg. Side across from the right angle is labeled what? Hypotenuse, and the other side is labeled the adjacent leg. So what's our trig ratio going to be here for sine? 10 over 26. Now it'll reduce to 5 over 13. Change that to a decimal. You can do that on your own. Cosine. Cosine is adjacent or hypotenuse, so 24 over 26. Somebody reduce that for me before I write it down. I don't feel like writing it twice. 12 over 13, and then you need to change that to a decimal. Tangent. Right, tangent deals with opposite over adjacent, so 10 over 24, which reduces to 5 over 12, and again, you can change that to a decimal on your own. So that's part of your answer, once you get the decimal forms there. The other part's the angle S. Well, when we go to do angle S, when we're dealing with angle S instead of angle R, what's going to change? Does the hypotenuse change? The opposite side now is that for angle S, and this over here is the adjacent leg. So the sine of S would be opposite over hypotenuse, so what would it be? Did you see that over here somewhere? Yeah, it was right there before we reduced it down, right? So that reduces to 12 over 13. You change that to a decimal, which you should already have the decimal answers over here, so that would make that easier. Number 2 on the 3rd page. They give us this triangle or something similar to that. 12, 16, that's a right angle. And this time we're looking for X. So we're actually looking for an angle this time. Remember, if you're looking for an angle, once you set up your equation, what's the first button you're going to hit on your calculator? The second button. We got to label this triangle in relationship to the angle that we want to deal with so that we know which trig ratio we're dealing with. And this is the hardest part for most of you, is deciding what trig ratio you're going to use. The 12 here is going to be labeled what? Remember, you're doing the trig ratios. If you're doing the trig ratios, what's your 3 labels for your triangle? Opposite, adjacent, hypotenuse. So what's the 12 going to be labeled this time? 16 is labeled. And then this other side over here is the adjacent. Again, this is the hardest thing for most of you to pick out, is you don't know which trig ratio to use. So if you're watching right now, you'll figure it out. Which of these sides do we not care about? We don't care about the adjacent. So we care about these two. Well, in SOHCAHTOA, which trig ratio deals with opposite, be careful, opposite and hypotenuse? put an extra letter on the end there.
Sine.
Sine. Opposite and hypotenuse. That's why the SOHCAHTOA comes in handy. All right, so we know we're going to do sine, and every single time, anytime you're using the trig ratios, you write in the equation. Sine, your trig ratio goes, you write it down, then your angle always comes next. Well, what's our angle this time? So the trig ratio, angle, maybe it would help. You do trig ratio, angle, equals, then your proportion on the other side, or your, I'm sorry, your ratio on the other side. So sine of x equals, sine is opposite over hypotenuse, so what's the opposite side this time?
12/16.
Now all you got to do, finding the angle is actually easier, but this is the one that most people seem to have the most trouble with. All you got to do, grab your calculator. What button am I going to hit first?
Second.
Hit second. What trig ratio do I hit?
Sine.
And then I just punch in 12 divided by 16. What's that give us? Can't use that calculator there to help me out. After I've been staying after school helping you and stuff, and you can't even do me a little favor. I think your calculator's backwards, isn't it? So you gotta hit this divided by this, then second sign. I think. What is yours? Yeah, 'cause yours doesn't print across the screen. Says what? 12 divided by 16. No, don't hit second yet. 12 divided by 16 equals, gives you some crazy decimal, right? Now you hit second and sign, and then equals, unless it breaks. What's it say? So we'll say about 49 degrees. So x is approximately 49 degrees.
Before we leave, can we do one on the very back side of this?
Be ready to
So I
ask.
know how much.
Be ready to ask the next one. 6 on the third page. This angle 64. These two, that last one that we just did, Kaylee, and this one, all the word problems are the same thing. It's just in words instead of. So that's 64, this is 15, we're looking for this. Which angle are we going to deal with this time? 64, how come? That's the one that we know, that's one they tell us. We label the triangle, what's this side over here going to be labeled? That's the opposite leg, this side's the hypotenuse, and then this side is the adjacent. Which one don't we care about this time? So we care about the adjacent and the hypotenuse. Which trig ratio deals with adjacent and hypotenuse? Remember, SOHCAHTOA.
Cosine.
So we write down cosine. What's our angle this time?
64.
Every single time you got to write out this equation when you're using the trig ratios. Cosine 64 equals, remember that this is the co part, so what over what?
Adjacent.
Adjacent over hypotenuse. Well, what's the adjacent this time?
15.
Over. Now this one's a little different than the other one because you can't just grab your calculator and let it do all the work. What you have to do is you have to watch carefully, and I'm going to show you. You have to put a 1, if I can get my pen to right, put a 1 underneath that every single time. Take your calculator, got to get rid of this word, so you take your calculator and you figure out what the cosine of 64 degrees is. So we take our calculator, and this time instead of hitting second cosine, you just hit cosine 64. Natalie, for your calculator, you got to do it backwards. So you hit 64, then cosine. And it's going to tell you some crazy long decimal. What's it tell us?
0.438.
We put a 1 underneath that,
15 breaks.
then we cross multiply. I'll do the hard part. 1 times 15 is 15. Is it to me? Going the other way, what's that going to give us when we multiply the other direction?
4383.
Just write that down, right? 0.4383. You guys let some of this stuff confuse you too much. What do you do next? Other one. Divide by the number with the variable, right? Don't let it confuse you. You know, if you had something like this, 16 equals 2x. Every single one of you knows how to solve that equation. You know, you're trying to get the x by itself. But then as soon as they throw in something that looks a little different, everybody gets confused. But you're still doing the same step, same process. What's going to happen to a number when you divide it by something like 0.4383? That's true. What else? Does it get bigger or smaller? It gets bigger. When you divide by something that's less than 1 whole, your number should get bigger. So if it doesn't, you punched it in the calculator wrong or something. What'd it come out to be?
34.
34 point what?
22.
0.22. So let's go out. Instead of rounding it off to the nearest whole number, let's go out 1/10. If it's a side of a triangle, usually you want to go out at least 1 decimal place. If it's the angle, I've been telling you to round it off to the nearest degree. So about 34.2. We put this in here. Mrs. Fagan was asking me questions the other day because she was helping somebody with their homework. And she said that on a problem like this, they got like 250 as their answer for that hypotenuse. Would it make sense for that hypotenuse to be 250? Probably not. And she knew that didn't sound right because this side was 15. That side's probably not going to be 250. So make sure that your answer makes sense. If this side's 15, does it make sense for the hypotenuse to be about 34? Yeah, it's probably all right. Back, I'll get it done real quick. I'm not going to draw this whole picture. What kind of triangle is this triangle? It's a 30, 60, 90. So we could use that, or we could use the trig ratios. I'm going to use the trig ratios since that's what we've been dealing with. We're going to use the 60-degree angle, so this side over here should be labeled what? Opposite. That one's the hypotenuse. Do we care about the hypotenuse this time? So let's get rid of that. This side over here then is labeled adjacent. Which trig ratio deals with adjacent and opposite? SOHCAHTOA. Tangent, right? TOA. So tangent, what's our angle? And then it's TOA, so 35 over x. Put a 1 under this. Somebody help me out. What's tangent of 60 real quick?
I think it's 20.
The whole answer is 22.
Yeah, I got 20. I did this all.
If you have that equation, that'll give you the answer. All right, just figure out what the tangent is. Make sure you grab those 2 worksheets if you haven't already. Did I just hand you those 2? Oh no, they're laying right there. I was going to hand you those 2. Grab those 2 worksheets if you haven't already. The packet and the 2 worksheets due next time.